Hello guys, welcome back to my channel. Based on African motives, still working on mathematics for N1 level. So actually in this platform we shall just have to see how we were supposed to answer this question paper, which was actually written recently, 27 June 2022. So we just want to see how we are supposed to answer this, and it's an X paper. So we shall just quickly rush through the question paper. As we all know, guys, the instructions that we are given, and we are supposed to take note of the instructions. And also it's a 3-hour paper that we had, and please take note about the graph papers, the degree of accuracy to 3 decimal places, and so forth. All right, so without wasting much of your time, guys, let us quickly rush through the questions that we had. So on the first part there, we had to simplify each of the following without a calculator by using exponential laws. So take note, guys, we were given an instruction to do, that is an instruction that we had to apply. All right, so we have in this case, let's just write it down and see. We've got 5x squared over 3, and everything was actually being raised to the exponent of 2. So actually there we just have 2 marks to simplify. So guys, we know that whenever there is an exponent like this, it has to raise each and every term. So each and every term is supposed to be affected by that exponent. So this 5 is same as to the exponent of 1, then it is raised to the exponent of 2. So what you simply do is to multiply 1 times 2, which is going to give us 2. So that's what we just have there. So which is going to give us 5 to the exponent of 2. Then we have got x again. So this is 2 and 2. So 2 times 2, which is 4, everything over. So if we still have the same thing on this 1 and 2, so everything is going to be affected by 2. So which is going to give us 1 times 2, which is 3 to the exponent of 2, like that. So that is what we had. And 5 to the exponent of 2, we know, guys, is 25. 5 times 5, which is 25. Then we have x to the exponent of 4 over 3 to the exponent of 2, which is same as 3 times 3, which is going to give us 9. So that's actually what we had. So we're going to have 25 x to the exponent of 4, everything over 9, just like that. So let's see what we have here, which is another part on 1.12. So I'm just going to write it down. We had something like the square root of 25 x to the exponent of 4 y to the exponent of 3 over 125 x to the exponent of 2 y to the exponent of 4. So something like that. That is what we actually had, and it was at 3 marks for that. So actually, how can we simplify this type of an expression or a term that you're given? So we actually know that square root of 25 is going to give us 5. So this is going to give us 5, right? And we have got x to the exponent of 4, y to the exponent of 3 over this 125 can be written in terms of 5. Or you see, we could have also just said, if we don't know square root of 5, you could have maybe written as 5 to the exponent of 2 for 25, then to the exponent of half. So this half times 2 times a half, which is going to give us 5 to the exponent of 1, which is actually just one and the same thing here, as you can see. So there's just one and the same part here, which is the same as just finding this. Okay, then you have to write this 125 in terms of 5, which is actually 5 to the exponent of 3. We know that 5 times 5 times 5, 5 times 5, that's 25 times 5, which is 125. So it's 5 to the exponent of 3, x to the exponent of 2, y to the exponent of 4, like that. So actually, why are we doing this? So that we can apply the laws of exponents. Since we are dividing, we can actually subtract the exponents from this law. So which means we are going to have 5 to the exponent of 1 dividing to 5 to the exponent of 3. So it's going to be 1 minus 3. 1 minus 3, which is going to give us actually minus 2. We have got the same thing here. We've got x and x. So these two, they are dividing. So it's going to be 4 minus 2, just like a minus b. So 4 minus 2, which is going to give us a positive 2. Y to the exponent of, we have the same thing, 3 minus 4, which is actually going to give us minus 1. So that's what we have, and we can't just leave our answer like this, guys. We know from our laws of exponents, whenever there is a negative exponent like this, you write it in the denominator from this concept. X to the exponent of minus a is 1 over x to the exponent of what? Of a. So it's simply writing it in the denominator, but this part here is not affected by any negative exponent, so it is going to remain in the numerator like x squared over, these two are the ones that we are going to write now in the denominator, which is 5 to the exponent of 2 and y to the exponent of 1, which is just same as y like that. So it's going to be x squared over 5 squared, which is 25y like that. So we are going to have x squared over 25y. So that's actually what we're supposed to get. If you have any other way, let us meet on the comment section so that I will know how you did it or how you attempted that question. Okay, quickly rushing on 1.2, we are asked to simplify each of the following without a calculator again, but this time using logarithmic laws. So this time we have to apply the laws of logarithm to simplify the logarithm of 3 in base 9 plus the logarithm of 27 in base 9. Guys, they want us to simplify this without a calculator. How do we go about it? All right, so this is it, guys. As you can see, the bases are the same and we are actually adding, so we are just going to apply our laws of logarithm. Log a plus log b, provided that the bases are the same. Maybe we're talking about base m and base m. These two are actually going to multiply each other, a and b, in the same base of m. So that is the concept there. We're just going to apply that law. So since we are adding and the bases are the same, we're going to multiply 3 and 27. So 3 times 27, everything in base of what? In base of 9, just like AB in base M. All right, which is going to give us log 3 times 27, which is actually 81 in base of 9. Okay, so this is log 81 in base of 9 actually. Okay, so now the problem is we have to give this in simplest form. So this is not actually the simplest form because we can simplify further. How can you simplify further? Remember, we have to write this 81 in terms of 9, in terms of the base. All right, so how can we write 89 in terms of 9? So this is 9 to the exponent of 2, which gives us 81. So it's actually going to be log 9 to the exponent of 2 in base of what? In base of 9. Why are we writing this in terms of 9? In terms of 9, because we need to apply this law. Actually, this is the law that we need, but we can't apply it now because there is an exponent here. So we have to drop the exponent from this law that we have. Whenever there is an exponent, you can actually write it as p log m. So this is going to be 2 log, if you drop this exponent here, which is the number here, it's going to be 2 log 9 base 9 like this. Okay, now we have got log a base a, which gives us a 1, which is this log 9 base 9. So log 9 base 9 gives us a 1. So it's actually the same as 2 times 1, which is going to give us a 2. So that is the concept. Actually, when you are working with logarithms, you are not given any law. You have to apply this. You are not given anything there, but you have to apply the concept of your laws and simplify further. So that's what we had. And on 1.22 we've got the same thing again, but how are we going to apply that same thing there on 1.22? Because this is actually log 9 divided by log 3, where we are dividing logarithms. And remember that guys, there's this law from your laws of logarithm from the change of base. Log A base B like this can actually be written as log A over log B like that. So it means when the logarithms are actually dividing, I can interchange. I can just write it as a log of the number here and base. So this literally means that this can be written as in place of A, which is log 9 in place of A, then B, which is the base, in place of what? In place of the base, we've got 3. So as you can see, we are now having a normal logarithm that we are used to. And from this normal logarithm that we are used to, we have to apply the same concept just like the previous part to write our answer in terms of what? In terms of 3. So this 9 in terms of 3, we know that this is 3 to the exponent of what? Of 2, which gives us a 9. So this is actually going to give us log 3 to the exponent of 2 in place of 9, writing it in terms of what? In terms of the base, which is 3. So that is how you actually simplify. Then as we can see, guys, we are back to the same concept that we did in the last question, where we have to drop the exponent. So it's going to be 2 log 3 base 3. And I talked about this, that whenever the number and the base are the same, it gives us a 1. So it's going to be 2 times 1, which is 2. So we have the same answers there on this question and on the previous question. So actually you can use your calculator now to prove if these answers are correct. Actually, yeah, you can use your calculator just for proof, but not to use it to simplify. All right, so anyways, that's what we had. And on 1.3, write the following in exponential form, and they've got 2 marks for that, just to write in exponential form. So which is what is exponential form? Actually 0.25. This is log 0.25 in base 4, which is going to give us -1. So remember, guys, I talked about the relationship between the log form and the exponential form, which can be written as A is equivalent to B to the exponent of C. So this is exponential form and this is log form. So we've got the same thing here. As we can see, it's just a matter of changing. This is your A here, this is your B here, this is your C, as you can see. So as you can see, in exponential form, it can be written as A is equal to B to the exponent of C, which is your A in this case. This is your A. 0.25 is equal to B to the exponent of C, which is B is your base, which is 4 to the exponent of C, and our C in this case is -1. So this is what we actually needed. Just like that, guys. That's exponential form. Nothing much. Nothing much there. All right. Then the other question, we are actually given to divide. All right, divide this expression by x minus 4. So remember, guys, whenever you're dividing it, this is actually 2.1, and you've got 6 marks for that, to divide x minus by x minus 4, which is 12x cubed minus 34x squared minus 51x minus 20, like that. So that is what you actually had there, and you're actually dividing. And so remember the concept, guys, that I always talk about: divide, multiply back, subtract, drop the numbers, redo the steps again and again. So that's actually what you're gonna do. So if we got 12x squared divided by 12x cubed, actually divide by x, which is the first term, divided by the first term, and this is gonna be x into this, which is going to be 12x squared. As you can see, there are 3. So if you divide by 1, x is going to be 2 remaining. So we are going to have 12x squared, which is going to multiply back each and every term here. So it's 12x squared times x. So it's going to be 12x to the exponent of 3. 12x squared like this times x. So as you can see, we are adding now the exponents, which is going to be 3 minus, because there's a negative here, so it's 12 times 4, which is actually 48. So it's going to be minus 48x squared. All right, so guys, we know the concept that at this stage we have to subtract, so that we'll see what we are going to have from the 2. So let's subtract 12x cubed minus 12x cubed here is going to be 12 minus 12, that is 0, as you can see. So you've got minus 34 minus 48. So actually you can use your calculator like this, guys. Minus 34 minus 48, like this from your calculator. Okay, because this is negative, which is actually a positive at the end. So this is going to give us 14. So you're going to have 14x squared now. So it's 14x squared out. Minus 51x minus 20, like that. So this is what you're going to have actually. So you've subtracted because this is just dropping. Someone is wondering, where am I getting this? We are going to drop this up. Okay, then we do the division again. First term, 12x squared divided by 14x squared divided by x, which is going to give us 14x squared divided by x. So this and this is going to give us 14x actually. So we're going to have plus 14x. Then we multiply back, guys. Remember everything here. So it's 14x squared by x, which is 14x by x, which is 14x squared. 14x by minus. So this is actually plus and minus, which is minus. So 14 times 4, which is going to give us 56. Yeah, so that's 56x. All right, then we subtract because we have multiplied back, so we have to subtract the 2 and see what you're going to have. So as you can see, guys, 14 and 14, that's a 0 there. So we have got negative 51, negative 56. So we have the same thing, guys, negative 51, negative 56, like this. So from your calculator, this is going to give you 5. So you're going to have 5, but there is what? X. So it's 5x. Then we drop this last term, which is negative 20. All right. So divide again back. 5x, the first term, 5x, divide by x, which is going to give us x, guys. As you can see, 5x and x and x can cancel. You remain with 5. So it's going to be plus 5. Then it multiplies back, plus 5 times x, which is 5x plus 5 times minus 4, which is actually a negative 20 there. Then you can subtract again, and as you can see, these two are the same, so that's going to give us a 0 0 there, which means actually it means this x minus 4 is actually a what? A factor. So this is a factor there. We are referring to x minus 4 as a factor since we are not having a remainder. We are having a 0 0 there. So that was the concept, guys, and you've got 6 marks just to do that. And if you are to cross check, this does not factorize this further, but actually the question was just for you to divide. So this is to divide. So you have divided, and that's it. So just like that, guys, and you've got 6 marks in exam. 6 good marks. All right, anyways, let's see the other part, that is on 2.2, which was to add the following expressions. So you're given 2 expressions actually to add. So remember, when you are adding, guys, it's just a matter of writing. So I'm just going to write as it is 20x squared minus 12xy plus 10y squared. Remember, guys, I told you that whenever you are adding, there is no effect. Actually, you're supposed to write it like this: plus, then you open a bracket. This is what you're supposed to do. Then you write the other terms that you are adding there, which is minus 16y squared plus 14x squared minus 4xy, like that. This is what you're supposed to do. But plus does not affect anything, does not change anything. What I mean is that, this is what I mean, guys. If you expand by a plus here, the plus and the minus is going to remain like that. There is no effect. A plus and a plus does not change. All right. A plus and a minus is going to remain as minus. So actually, when you are adding, there is no need of you opening bracket. You just write the terms as they are. All right. Then now, from that, you have to take the terms x squared. You have got 20x squared here. When you've got 14x squared, collect them together, minus 12xy, like this, and we've got minus 4xy here, 10y squared and minus 16. So we've got plus 10y squared minus 16y squared, like that. All right, so at the end we have to add 20 plus 14, which is actually 34, x squared, minus 12 minus 4. These are like terms. We've got xy here and xy here, so you can subtract minus 12 and minus 4, which is actually going to give you minus 16xy. And here I've got like terms, 10y squared and this 16, so it's 10 minus 16, okay, which this is 16 or 6, this is 16. All right, so you've got 16 here, not 6. Okay, so it's 10 minus 16, which is actually going to give us minus 6y squared. Okay, I actually thought like I'm having a 6 or a 16, it's a 16 there, so it's going to give us minus 6y squared, just like that, guys. So if you have any part that is not clear, okay, let's meet on the comment section so that I'll know what you think. Remove the brackets and simplify. So this one was a straightforward question, guys. On 2.3, how do you remove brackets if you are given a squared like this? A squared means you've got two brackets which are multiplying each other, just like 2 squared is 2 times what? 2 times 2. So this literally means you've got x minus 3 into x minus 3, like that. So remember how you expand, so it's going to be x into x, which is x squared, x and minus 3, which is minus 3x. Okay, we are done with this x. It is multiplied each and every time. We move on to minus 3 and x, which is minus 3x, minus 3 and minus 3. So take note, this is a negative and a negative, which is going to give us positive 9. So we have expanded the brackets, but the further part is and simplify, which means we have to simplify wherever it's possible. So which means we're going to have x squared. We can collect like terms here. We've got x and x, so it's minus 3 minus 3, which is minus 6x plus 9. So actually that's what we had, just like that, guys. And you've got 3 marks. You've got 3 marks, and which actually makes a total of what, of 12 marks for question number 2. And that's what we had. And on question 3, we had the same thing where we have to factorize, fully factorize. Take note, fully factorize. Okay, so how can we actually factorize that part? Is it possible, guys? Is it possible? X plus y in brackets like that, minus 5xy minus 5x squared. Okay, so the tricky there, the tricky, guys, here this is where we had the tricky here, is that we've got 1, 2, 3 terms, so we can't factorize them. So the only thing that we can do is to expand the bracket so that we can have 4 terms. So 1 is actually expanding. If there is no number like that, it means there's a 1. If the number is not indicated, it means there is a 1. The number is there, but it's not indicated. So that's 1 times x, which is going to give us just x plus y there, minus 5xy minus 5x squared. So what is the purpose of expanding like this? What is the purpose? So that we can have 1, 2, 3, 4 terms. So now we have got 4 terms, so which means factorization is possible. But how is it possible? We have to do it by grouping. Remember, we have got factorization by what? By grouping. So we have to group in a way that we can actually factorize. Here on these two, there is nothing common. So we can take terms with x together, which is x, and here there is also an x here. Take note, but there is a y here, so we are going to take this one with complete x so that it can actually make sense. So it's x minus 5x squared. Okay, you take these terms with y together, these terms, this one, there is y here, there is y here, so we are going to write them together here. So it's plus y minus 5xy, like this. That is by grouping, so that you can now factor out what is common for the first 2 terms. Now you group them into 2 like that. So for the first 2 terms, these ones, what is common here? As you can see, x is common, and the highest common factor is x, the one with the smallest exponent. Remember, you factor out x, then you divide x divided by x, which is 1, minus 5x squared divided by x, which is minus 5x. Remember guys, minus 5x squared divided by x, so this is going to be x here. Okay, then what is common on these two brackets, so that whatever that we are going to have must be the same as this bracket. So this is going to be plus y here. So plus y divided by plus y is going to be 1, minus 5xy divided by y like this, minus 5xy like this, divided by y. Like, as you can see, y and y is going to cancel. You remain with minus 5x. So this is the idea of factorization. As long these two brackets are the same, it means now we can factor out that bracket which is the same. We can factor it out, and once we factor it out, we are going to remain here with x, and here we are remaining with plus y, which is going to be written in another bracket. So that is the whole idea of factorization. If you are working with 4 terms, try by all means to do it by what? By grouping, guys. All right. As long as you have got 4 terms, you have got the power to do the grouping depending with the terms that you are given. If it is actually possible to do that, then we have on 3.12 this time we had nothing that we can do actually here, because we have got 3 terms, and we can't expand anything like the previous part so that we can have 4 terms. This time it's actually impossible for us to do that. So now, if it is impossible to do that, and you've got actually 4 marks for that here, and you wonder why 4 marks. So actually, on a condition like this, because we've got 1, 2, 3 terms, it's impossible for us to do grouping method. It's for 4 terms, that method. So now what we can only do is to check each and every term if there is anything common in each and every term. Like here we've got 1/4, 1/4, 1/4. It's common, so which means we are going to factor out 1/4. All right, we move on to x. We've got x squared here, we've got x to the exponent of 3. But remember, what you factor out here is the highest common factor, so you're going to factor the least one with the smallest exponent, which is x. You move on to y. Y here is there, yes there, yes there, which means it's common, but you're going to factor out the one with the least or the smallest exponent, which is this one, which is y. So this is your highest common factor, the one that you factor out. Then now you can divide. So that is factorization, guys. What you factor out must be the highest common factor. All right, so as you can see, guys, if you divide 1/4 and 1/4 will cancel, and we've got x squared divided by x, which is going to give us x. Y and y here will cancel. All right, then here we've got 1/4 and 1/4. This one is going to give us a negative because there's a negative here. X and x will cancel, so we are going to remain with y to the exponent of 3 divided by y. As we can see, here there are 3, here there is 1, so it's like this. So you are going to remain with 2. Here there are 3, you divide by 1, so which means you are going to remain with 2. So it's going to be y to the exponent of 2. The same thing, 1/4 and 1/4. This will cancel. X to the exponent of 3 divided by x is the same thing like what we had for y there. So it's going to be x to the exponent of 2. Y to the exponent of 2 divided by y, which is going to give us a y like that. So as we can see, inside the bracket there is nothing common. There is nothing. We have got x here, here we do not have x, even though here there is x, but here we don't have, so it means it's not common. We've got y here, we've got y here, but here we do not have y, so which means y is not common. So it means this was actually the correct highest common factor that we were supposed to have. So that's how actually these questions are, they might be asked. So on the first question, you're asked to determine the prime factors of each term. So you've got this term here and this term. So the prime factors, guys, remember, if you are given 120 to express as a product of its prime factors, you have to reduce this number by the smallest possible number, which is the smallest possible prime factors here, which is actually the smallest number that we have is 2. Okay, so it's 120 divided by 2, which is going to give us 60. You try again, 60, you try 2 again, the smallest number, 60 divided by 2, which is 30. You try again 2, 30 divided by 2, which is going to give us 15. 2, as you can see now, 2 is no longer a factor of what? Of 50, because it leaves a remainder. So you're going to try 3. So 15 divided by 3, which is going to give us 5. 5 is no longer a factor. 3 is no longer a factor of 5, because if you divide, it gives you a remainder. So you're going to try 5. So 5 divided by 5, which is 1. Now, as we are at 1, this is no longer a prime number. So it means these are the numbers that we need to give us 120. But here we are given it as 120 x to the exponent of 6, y to the exponent of 3, z to the exponent of 2. This is how we are given this number here. So actually we are going to write this as, this is 2, it was supposed to be 2 times 2 times 2, which is 1, 2, 3. So you can write it as 2 to the exponent of 3 times, we only have 1 3 here, so it's going to be 3 times, we only have 1 5 here, so it's going to be 5. So you can even write it as to the exponent of 1 to the exponent of 1 if you want, but you can just leave it as 3 and 5. If you want, you can write it as to the exponent of 1. All right, then these ones you just write them as they are, which is x to the exponent of 6, y to the exponent of 3, z to the exponent of 2. So you can even multiply if you want, or you can just write it as direct as it is. Okay, so you do the same thing for 45. So as we can see, guys, 45, just applying the same concept, we're going to start with 3. 2 is not a factor of 45. Here there is 5, guys, so you can't try 2. So 45 divided by 3, which is actually 15. You move on, you try 3 again. 15 divided by 3, which is 5. 5 divided by 5, which is 1. So that's 45 is 3 times 3, of which 3 times 3 is same as what? As 3 squared. So you can write it as 3 times 3, or you can write it as what? As 3 squared. But this was 45 x to the exponent of, you write everything there, x to the exponent of 3, y to the exponent of 4, z to the exponent of 3. So it's going to be 45, which is 3 to the exponent of 2 times 5. So we have got 3 to the exponent of 2 times 5. That is your 45. Okay, now, so this is actually 3.31. All right, so this, the rest part you just write as it is, x to the exponent of 3, y to the exponent of 4, z to the exponent of 3. This is z to the exponent of 3 there. All right, so that is the prime factors to write as the product of prime factors of each term. That is what you just need there. Then 3.32, the lowest common multiple, which is actually the LCM. So remember, guys, I told you about the LCM, that LCM, you have to take each and every term that is there, each and every term that is there. But if the terms, they are repeating, or if the terms are occurring many times, you have to take the one with the highest exponent. All right, so you take the one with the highest exponent, but the concept is that you take each and every term. All right, so the one with the highest exponent is this one. For 2, we're going to take this 2 to the exponent of 3. All right, we move on to 3. Yes, here we've got 3, here we've got 3, but this one is the one with the highest exponent, which is 3 to the exponent of 2, or if you wrote it as numbers, you're going to write 3 times 3 times 3, where there are main of them. Okay, here I've got 5 and 5. This is actually the same exponent, so you're just going to take it once. All right, x here and x here, the one with the highest exponent, it's x to the exponent of 6. Y here and y here, the one with the highest exponent, it's y to the exponent of 4. We've got z here and z, the one with the highest exponent, it's z to the exponent of 3. So LCM, remember guys, you take the one with the highest exponent. Okay, so if you multiply these numbers, you're going to obtain 360 x to the exponent of 6, y to the exponent of 4, z to the exponent of 3. So actually that's your LCM. And on 3.34, we now need the highest common factor. So guys, remember the highest common factor, I told you that it must be common. That's the first thing. It must be common. After that, you take the one with the smallest exponent. It's common, and you take the one with the smallest exponent. Okay, so 2 is not common here. We do not have 2 here, so you're not going to take 2. Okay, we move on to 3. We've got 3 here, we've got 3, but which one has got the smallest exponent? So it's this 3 to the exponent of 1, which is same as what? 3 times, we move on, 5 here is common also, and it is the same exponent, so you're just going to take it as 5. All right, x is common, but which one has got the smallest exponent? So it's x to the exponent of 3. Okay, y is common here, but which one has got the smallest exponent? So it's y to the exponent of 3, and the same thing with z, z to the exponent of 2, the one with the smallest exponent this time. So 3 times 5, which is 15, x to the exponent of 3, y to the exponent of 3, z to the exponent of 2. So actually that's what we just had. Therefore, the highest common factor, the LCM, whatever that we had. So that's what we had, guys, the highest common factor, and this made a total of 18 marks on question number 3, which gave us a total of 18 marks from this question. Guys, I'm seeing that I left this question here. Oh guys, this one, I didn't talk about this question. Actually, I left this question, I don't know how. Okay, anyways, let's just see that part. On 3.2, I'm seeing this question. We didn't do this question actually. All right, anyways, let's see. So here we are subtracting, guys, and we've got 5 marks for that. Oh, a lot of marks that we had left there. 5 marks. So how are we going to subtract such type of a question? Actually, remember, whenever you're subtracting, you have to find the LCM or the LCD of the given denominators here. So our LCD or the LCM is going to be x, and is common here, so you're going to take x squared y like that. So that's our LCD, the lowest common multiple. So as you can see, that's the LCM there. So remember that you divide, guys, back your LCD here, divide by the denominator here. So it's actually like x squared y divide by x like this. So as you can see, x into x squared, you're going to remain with x. So it's going to be xy, which is to be multiplied by 3. Okay, so it's xy times 3, which is just 3xy, guys, minus. Okay, so as you can see here, x squared y divide by x squared y, these two, they're actually the same, so you're going to obtain 1, but there's a negative here, so it's going to be minus 1 into 5xy like this, minus 4. So whenever you see a negative, take that negative with a pinch of salt. All right, take a negative with a pinch of salt whenever you see it. So this negative is going to expand the whole bracket. So 3xy here minus 1 times 5xy, which is minus 5xy like that. Now we've got minus 1 times minus 4, which is going to give us a plus because it's negative and negative, so that's a plus there. Everything over x squared y. So collecting like terms, because we've got xy here, so it's 3 minus 5, which is minus 2. So we've got minus 2 xy minus, okay, this is a plus, sorry, plus 4 over x squared y, like that. So actually you can decide to leave your answer at that stage. Yes, you can factor out 2 because 2 is common on the numerator there, but you can actually decide to just leave it like that. So it depends with how you want to simplify it further. Okay, on 4.1 we are given to solve the equation, which is 6 marks for that, guys. This question paper had a lot of marks actually. If you saw that we had questions with a lot of marks which were actually given there, which is actually good if you have to obtain these marks, and bad now if you lose each, because there were actually a lot of marks. All right, so anyways, here we are given to solve for x. Actually, to solve for x is to find the value of the unknown. To find the value of unknown, which is the unknown is x. So we've got brackets here, so what we just need, guys, is to expand brackets, as you can see. So it's going to be negative 4 times x, which is negative 4x. All right, negative 4 times negative 1, so this is negative and negative. Actually, it's going to give us positive 4, which is equal to negative 5 times 2, which is negative 10x, negative 5 and negative 1, which is going to give us a positive 5 because it's negative and negative. All right, this minus 19, it's not part of the bracket, so you're just going to subtract it. It's not affected by the bracket. All right, so this is what I'm gonna do. I'm just going to simplify this part here together. 5 minus 19, which is minus 14 there. All right, then after that I can actually collect like terms, because I've got terms with x here, so I can take them to one side of the equation, and the moment this crosses the equal sign is going to add, so it's going to be a plus, so it will be minus 4x plus 10x. Then I actually transpose this 4 to this side. It was a plus, so it's going to be a minus, so actually it's going to be minus 14 minus 4. This plus is now a minus 4. This 10 taken to this side is now a plus, so this is taken here and this is taken to the other term. That is collecting like terms. All right, so minus 4 plus 10, which is actually going to give us 6x, and this is minus 14 minus 4, which is minus 18. All right, so this is going to give us minus 18, definitely divided by 6 by 6. So therefore our x is going to give us a negative 3. 18 divided by 6 minus 18 divided by 6, which is actually a negative 3. So that's what we had. And on 4.2 it's actually now to manipulate the given formula and make R the subject of the formula. So that is to manipulate. So to manipulate is just to change something into another thing that you want, or how you want it to be represented in terms of v or in terms of h. So this is in terms of r, so we are going to divide by pi and h, because these two, they have got nothing to do with r here, but they are multiplying, so we have to divide. So that literally means we are going to remain with r squared here, which is equal to v over pi h, like that. And how do I remove that squared, this squared here? So the opposite of square, we have to introduce the square root, and we actually know that the square root of any number is a plus or minus. So it's going to be plus or minus the square root of v over pi h, just like that. Just like that, guys, just like that. All right, I'm not going to throw this away because we have to use it here, because here we are now asked to use the answer in question 4.2. And in 4.2, what did we do? We made r to be the subject. Now substitute the following values to calculate the radius. Okay, they are now telling us that it's a radius, but they didn't tell us, they just said manipulate the formula. Anyways, this is what we have. So if it is a radius, there's no need for us to write plus or minus. All right, So we have to calculate the value of h. We have to substitute h and v, which is h is 9 and v is what is okay. Our r there was actually, we obtained the square root of v over pi h. So actually guys, if they say this is a radius that we are talking about, which means I'm not going to put plus or minus, but there we are not given that. We know that this is formula for the volume of a cylinder, but this is just a formula. No one told you that it's a formula for the volume. All right, so you have to use plus or minus, but this time our answer is just going to be a plus because you are calculating the radius. Okay, so I'm just going to take the positive part of the formula now. So which means our r is going to be the square root of v, which is the volume, which is 33. So we have got 33 over pi times h, which is your h there was 9. So it's just a matter of substitution, and make sure that everything is covered by the square root like this on your calculator. Everything is actually covered by the square root so that you can obtain an answer like this, which is 1,8, 1,0, not 8, 1,0 8034, something like that, which is actually 1,080. And remember, we are supposed to leave our answer to 3 decimal places, so it's going, that's what we are going to have there. Then on 4.4, which is actually to conclude the whole question and make 15 marks there with 5 marks of the last part of the question, of which is 4.4, we are given a motorbike covers 120 kilometers in 1 hour 15 minutes. All right, calculate the time in hours and minutes it takes to cover 250 kilometers if the average speed remains unchanged. So if the average speed remains unchanged, it means this question can be answered different ways. You can actually use simple proportion here. Okay, but let's first write something here and make it clear. We are given a distance of 120 kilometers, and actually the time that is given, it's 1 hour 15 minutes, and we know that our time is supposed to be written in hours if this distance is kilometers. So 15 minutes in hours, remember we have to divide by 60 this one, so it's going to be 15 over 60, which is going to give us 1 over 4. So which means our time is going to be 1 plus 1 over 4. So it's 1 plus 1 over 4, which is 1 and 1 over 4 hours. Or you can write it as a decimal, 1,25 hours. So this is our time. All right. Then on the second condition, we are just given a distance of 250 kilometers. And we are told that the speed here is going to be the same. For the same speed that is here, what is the time that you're supposed to have? So like I said, we've got 2 ways to attempt this question. Since the speed is the same here, we can actually apply simple proportion. Yeah, we can actually do that. We can actually apply simple proportion to say that when I am covering a distance of 120 kilometers, the time that corresponds is 1,25 hours. All right. When I am covering a distance of 250 kilometers, since the speed is the same, then what is going to be my time in hours? Just like that. So you can use simple proportion, guys. You can actually use simple proportion. All right, where you are now telling yourself that if this is 250, what is going to be the value here, which is more? So it's going to be 250 kilometers over what you are given here, which is 120 kilometers times the time in hours, which is 1,25 hours. So this is going to cancel kilometer and kilometer, and if you multiply 250 over 120 times 1,25, you are going to actually obtain 290 over 96. This is 290, 250, not 290, but 250 over 96 as a fraction, or you can have it as a decimal, and this was going to be an endless mode. Then you convert that to time in hours, which is the same thing as 2 and 49 over 48, like this, in hours. So it actually means you've got 2 full hours in this case, and you convert this now to minutes. Remember, before, when you were given minutes, you divided by 60 to convert to hours. Now you've got hours. In order for you to get back to minutes, you have to multiply by 60. So it's going to be 49 over 48 times 60. And this is going to give us now minutes, which is 36,25 minutes. So it's going to be 36,25 minutes. Remember us to give our answer in hours and minutes. So you can actually do this proportion, or since the speed is the same, you are going to calculate the speed here, provided, for this first condition here, we're going to calculate our speed. We know that speed is distance over time. So we're actually going to have our distance of 120 in kilometers over time in hours. Okay, so it's 120 kilometers over time in hours, which is 1,25 or 1.25 in hours, provided that your time is hours, guys. Okay, and this is going to give us 96 kilometers per hour. If this is in kilometers and this is hours, it's going to give you kilometers per hour as your speed. So the speed is going to remain the same because we are told that it's unchanged. So here we have got the distance and the speed, which is unchanged, of 96 kilometers per hour. That is our second condition, and we want now to calculate the time. So we have distance and speed, and we want time. So remember that time is equal to distance over speed. So the distance is 250, the speed is 96, so it's 250 over 96. Okay, so this is your time in hours if you do that. So as you can see, guys, 250 over 96, this one is the same answer that we had here, 250 over 96. So which means you're going to do the same conversion. It gives you 2 and 49 over this, which is going to end up with 2 hours 36,25 minutes. So that's what we had, guys. So we could have calculated the speed because we are told that the speed it remains unchanged. It remains unchanged, which means it remains constant. There is no change there, so it's actually the same thing. It's something like that. So that's what we had, guys. The only thing that changed was the distance, not the speed. Okay, then on 5.1, there on question 5, we are asked to write the equation in standard form. So you're actually given an equation okay, which is a 5x plus 2y is plus 3. That was plus 3 is equal to 0, like this. Okay, so that was the equation, guys, and you're asked to write this in standard form. So remember, the standard form we have to write in the form of y is equal to mx plus c. So that's gonna be 2y there is equal to transpose x to the other side, which is going to be minus 5x, 3 to the other side, which is going to be minus 3. But still, there is not y here, there is a 2y. So how are you going to remove this 2? We divide by 2 by 2 by 2. So this is 4x, guys, not 5x. This is 4x. All right, so this is gonna be y is equivalent to minus 4 divided by 2, which is minus 2x minus 3 over 2, like that. So that is the standard form. Okay, then determine the gradient from that. Okay, so remember, guys, the gradient, once you write in this format, m is the gradient. So m here, which is minus 2, so the gradient in this case is minus 2. All right, Then on 5.13, what do we need there? Which is the y-intercept. Determine the y-intercept. So the y-intercept is going to be minus 3 over 2. So that is our y-intercept there. Y is equal to minus 3 over 2. So actually that's the condition that you are given there, and just have to write it that way. Then the other question again, given xy is equal to xy minus 6, this is xy minus 6 is equal to 0 there. Then write down in the standard equation. So you know that the standard equation, guys, we're actually going to be given y is equivalent a over x, which is actually taken from xy like this is equal to a or is equal to c. So you can write in any way. So which means writing in this format, we are going to have xy, which is equivalent to 6 to this side, which is going to be a positive 6. Then y is equivalent to a over x, which is or c over x, which means you have to divide by x, which is 6 over x. So that's what you just have there. In which quadrants should the graph be drawn? Okay, so you're supposed to know from this one, if it is a positive, if this is a positive like this, it means your graph is going to be like this in the first and also in this quadrant. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So it's the first and the third quadrant. That is where we are going to have our graph, in the first and third quadrants. First and third quadrants. Alright, so the question is actually asking you that in which quadrants should the graph be drawn? Where are we going to see this graph? Okay, so that is what you actually had. And on 5.3 now we are given that 2 is equal to minus xy. Copy the table in the answer book and fill in the values of a, b, and c. Okay, so we're asked to copy this and we have to fill in the values of a, b, up to c there. So guys, we have got a lot to work on there. Okay, so let's just have our table down and see how are we supposed to fill in. This is actually taken from the equation of 2 is equivalent to minus xy like that. So actually using that concept, you can actually divide by minus x, which means y is equivalent to 2 over minus x like this, which is the same as y is equal to minus 2 over x. It's just one and the same thing. So it can make easier to calculate the values in this way, or you can even use this same equation. It's one and the same thing actually. Okay, but here we are asked to copy, so just as an instruction, that's what we had, guys. So this is an instruction, so we've got nothing than to just redraw. We are not asked to just calculate the values of a and what of a, b, and c. No, we are asked to duplicate, to copy, and complete. So there we are not just about copying, it's about copying and completing. So this is your x and your y there, guys. So some of the values actually they were there, minus 8 and minus 6. These ones we were given 0.25, minus 6, 0.33, but on minus 4 we are not given anything now. On this one, minus 4a, so x is minus 4. Actually here it's x, which is minus 4. So what is going to be the value of y? So actually you can just substitute in either of these equations here. Since we have this one, which is minus 2 over x, x is minus 4, so it's minus 2 over minus 4, which is going to give us 0.5. That's a half there, which is actually 0.5. All right. Then we move on to minus 2. We are given minus 2 and 1. This is minus 2 and 1. Then 2 and b. Then so we need 2 here, and what is going to be the corresponding value? So this is the value of x. So just substitute here 2 minus 2 over 2, which is going to give us minus 1. So we've got minus 1 there. All right. Then another part is this time we are given the value for y, and we need the value for c, and y is negative 0.25. What is the value for c there? All right, so this is the case, guys. You can substitute here or here, so you just choose 2 is equivalent to minus xy, like that, and y is minus 0.25, y here, so it's 2 is equal to minus and minus 0.25. So it is going to cancel, so it's going to be 0.25x divided by 0.25 both sides by 0.25 both sides. So your x is going to be 4. All right, so this is going to be 4, like that. So guys, these were the values that we're missing from 5.31 there. So we had to we are asked to copy the table there, to copy and complete. Now we are now asked to say, using the table in question 5.31, now draw the graph on the graph paper. Okay, so we have got the values here, guys, and okay, here I just made from my own graph paper here, guys, another type which is actually different from the one that you have in your question paper, in your exams there. So actually this is it, guys. I'm just going to mark out the point, because here the tricky part is that you just need to mark the points, okay, from the ones that you just made here. As you can see, you've got x, the values of x and the values of y there. All right, so you just need to mark minus 8 for x and y, which is 0.25. So here, as I can see, I have made this whole box to be 0.5, so which means 0.25 it's half of what? 0.5. So I'm going to have it somewhere here, 1 2 3 4 5, half. So as for me, I'm going to have it in between these two boxes. That's where I'm going to have it, minus 8 and that value, then minus 6 and 0.33. So this is my minus 6, and 0.33 is actually like this. I'm having 0.1 is I'm having 0.1 here, 0.2, 0.3. So 0.33 I can just make maybe an approximation where it can be. All right, so it's just like an approximation because it's not like exact. All right, then minus 4 and minus 0.5, minus 4 here and positive 0.5, sorry, minus 4 and positive 0.5. So it's minus 4 here, now at positive 0.5 direct. This one is a direct point. You mark that point, so actually make sure that the points are visible and so forth. Minus 2 and positive 1. So this is minus 2 and positive 1, which is somewhere here. All right, so this piece is done. We move on to another piece here, which is actually of 2 and what? Minus 1. So it's positive 2 and minus 1 here. Positive 2 for x, y is minus 1, which is somewhere here, 2 and minus 1, and c, which is 4 and minus 0.25. so remember 0.25 it's in between 0.5 and 0 there, but this one is a negative, so I'm just gonna count 5 boxes down, 1 2 3 4, just in between somewhere here. That's it. That is where I'm having it, in between what? In between minus 0.5 and 0. It's just in between the two lines. So actually you have to sketch, so you have to like join these points just like that. All right, so it's supposed to be a curve like So just a curve, guys, that you're going to have. So as you can see, we are going to have a piece in this quadrant and another piece in the other quadrant. So guys, you can make it smoother than the one that I'm having here, and also you join this piece, so it's not like a straight line, it's a curve, this one. All right, so it's a curve, not a straight line. So actually that's what we had, and we were given this as 2 is equivalent to minus xy, or you can just write it in any other way that you can actually have. But guys, you can actually do much better than this. Actually, you can do a much better diagram than this one that I'm having. But that's what we had, guys, on this question, and this was actually to mark 18 marks on question number 5. We've got 18 marks for that. And question number 6, now we are given two triangles, where we are given that triangle ABC is actually similar. So these are similar figures to triangle DEF. So this is ABC and this is DF. These two triangles, they are similar to each other. Then you are given the dimensions, which are also on the triangle. So the first question on 6.1 is to calculate the length of the side BC by using the theorem of Pythagoras theorem, which is this BC, the length of BC. So actually our Pythagoras theorem is given on our formula sheet, or we can just apply this, guys. We know that here from the Pythagoras theorem, c squared is equal to a squared plus b squared from this type of a triangle that we have. And as you can see, this is our C and this is our A and this is our B. So we can actually apply our Pythagoras theorem direct, guys, there, which is c squared is equivalent to a squared plus b squared. So in this case, our c squared is 10, which is the hypotenuse, the one opposed to 90 degrees. So you've got 10 squared equal to a and b squared. So a and b, these are the shorter sides, which is ac and bc. So you can just have your 8 squared plus bc squared, depending on how you want to write it there. And what you want to calculate is bc squared, so it's like you have to transpose. So 10 squared, that is 100, is equal to 8 squared, which is 64, plus bc squared. All right, so we can transpose this to this side, which is 100 minus 64 is equal to bc squared. So 100 minus 64, which is 36, is equal to bc squared. All right, so to find bc, guys, we know that we have to introduce the square root to remove the square. So therefore bc is going to be 6 meters. So this is actually meters, guys, from the dimensions that we are given from the other diagram. These are meters, so this is going to be 6 meters. Okay, so something like that. Okay, then calculate the length of the side DE. Okay, so this is the side DE. So for DE, I can actually use the ratios, or actually I can use similar figures, because here I'm given an angle here of 53.13 and I'm given 20 meters. So I can actually apply the ratios, or I can apply similar figures. Okay, you've got two options there to apply ratios, but since these are similar figures, we can apply the concept of what? Of similar figures, because we know that from similar figures, let me just write it down. Triangle ABC is the one that is similar to triangle DEF. So this is what we are given, guys. Okay, so you know that from similar figures, ratio of sides is equal. So AB over DE is going to be equal to BC over EF. All right, which is equal to AC over DF. That is the corresponding part. Okay, so we have to fill in, guys, what we want to calculate and what we are given. So DE and the ratio with the DE, this is the ratio with the DE. So it's AB over DE, and AB, do we have AB? AB, we have got AB, which is 10. So it's 10 over DE, which is equal to BC over EF. Okay, BC, we have got it, but we do not have EF, so we are not going to take this ratio. We move on to another one. AC over DF. AC is there, DF is there, so AC it's 8 over DF, and our DF is 20 here. That's our DF, which is 20. So actually to find DE, as you can see, is the only part that is remaining here to find DE. So you can actually cross multiply. Okay, so that's 20 times 210 there, which is 200, is equivalent to DE times 8, which is 8 DE. So how can I calculate DE, guys? This is multiplying, so actually I have to divide so that I can find my DE, which is 200 divided by 8, which is going to give us something like 25 meters. So that's our DE there, just like that. So like I said, you can use simple proportion, you can actually use other ways, or you can use those ratios and so forth, or you can just use these from the ratio of sides, which is the same. And on 6.3, calculate the magnitude of angle D with reason. So this is our angle D. D is on this triangle, this one. So you actually know that angles in a triangle, guys, they add up to 180. So that means angle D is going to be 180 degrees minus all these angles which are inside. This is 53.13 and this is 90 degrees. Remember, there's a right angle there, 53.13 degrees plus 90. If we add these two angles from 180, why? Because we're talking about angles in a triangle, guys. That's the reason. Angles in a triangle add up to 180. So if they add up to 180 degrees, I'm just going to subtract the two angles from 180, so that will be my resultant, and that will give us 143.13, and from 180, which is going to give us 36.87 degrees. So actually that's our angle D. So that's what we had there. And on question 7, okay, so this was actually 7 marks, as you can see, guys. And question 7, the illustration shows a ladder. So we've got a ladder that leans against a tree. All right, calculate the length of the ladder if the angle of elevation, so we want this length of the ladder here, and this is your tree. So actually, as you can see, guys, we are forming a right angle triangle there, and you can actually use those ratios to calculate this side, just like what we wanted to do on DE there, to use the ratios for you. So this time, that is where I'm going to apply those ratios now. So as you can see, from this triangle here, we are given the height of the tree, which is your opposite, and here this is what you want to calculate, which is the length of the ladder, which is your hypotenuse, because it's opposite to what? To 90 degrees. So which ratio that uses opposite and hypotenuse at the same time, which is opposite and hypotenuse at the same time, A and C, you're going to see that it's sine from the ratios of what? Of theta. So sine theta is A over C, which is opposite over adjacent. All right, so I'm going to use that to calculate on 7.1. So I'm going to use sine theta is equal to opposite over hypotenuse. So our opposite, that one is the one that I'm saying, A over C. So in this case, this is your A and this is your C. So we are going to have sine 49 degrees, which is the angle. Sine 49 degrees, which is opposite over hypotenuse, which is A over C. This is 5, whatever that you are given there, 5,283 meters over the hypotenuse, which is the one that we want to calculate, which is our C. So you're just going to put it as X. I don't know what is best for you there. I don't know what is actually best for you. So working out cross multiplications and so forth, so that we can actually calculate that X, we can cross multiply here, which is going to give us X times sine 49, which is X sine 49 degrees is equal to 1 times 5, this number, which is 5,283 actually, divide by sine 49 by sine 49. So we're going to divide by sine 49, by sine 49 both sides so that this can cancel and you remain with x. Alright, so if you divide these two, you're going to obtain 7,0000000, something like that, guys, and this is 4, something like that. Alright, so if you round off, it's going to be 7. So actually that is going to be the length, and this was in meters. So everything was in meters. So our length there of the ladder is going to be 7 meters. So therefore the length of the ladder is 7 meters. You can actually conclude like that, that the length of the ladder is 7 meters. Okay, simplify without a calculator by using special angles. So how are we going to apply our special angles? To apply sine 45 degrees times tan 30 degrees, because we have got these special triangles, special angles, they are given. So from our special angles here, we've got sine 45, which is sine 45 degrees. Remember, it's opposite over the hypotenuse, so it's 1 over square root of 2. So you've got 1 over square root of 2 times tan 30. According to 30 degrees here, this is tan 30, and tan theta is a over b, which is a over b, opposite over adjacent. So this is a b, so opposite over adjacent, which is 1 over square root of 3. So this is going to give us 1 over square root of 3. Okay, so that's what we had, and we can maybe multiply, combine the two, because remember our laws of sets can allow us to do that. So it's 1 times 1, which is actually 1 over 2 times 2, because these numbers, they are under the square root, so they can actually multiply each other. So that's what we have. Or we can actually rationalize the number here by multiplying both sides, the numerator and the denominator, by what? By the denominator, which is square root of 6. So 1 by square root of 6, which is square root of 6, over square root of 6 by square root of 6, which is 6. From this law, square root of a by square root of a gives us a. So square root of 6 times square root of 6 is actually 6 there. So we can actually give it this way, or maybe just leave it like that. But that's what we had there. That's what we had. And draw the graph of y is equal to sine x between 0 to 360 on the graph paper. All values of the points of intersection with the system of axes and the turning points where applicable must be shown, and that's 5 marks to make it a total of 10 marks for this question. So actually, for you to sketch or to draw the graph of y is equal to sine x according to what we are given, and in the interval that we are given from 0 to 360 degrees. Okay, so this is it, guys. I'm going to use the 90-degree interval. Okay, this is now something else. Okay, so I don't know, let me put it this way. So like I said, I'm going to use the 90-degree, like I'm going to space it by 90 degrees. So this is my x and this is my y. All right, so I'm going to space this by 90, 90, 90 to up to 360. All right, so that's going to be 0 degrees, 90 degrees, 180 degrees plus 90, 180 plus 90, which is 270, 270 plus 90, which is actually 360 degrees. Actually, like this is going to be easier for me because I'm just going to use my calculator to simplify. Sine 0, I'm just substituting here. Sine 0, which is a 0, sine 90, which is a 1, sine 180, which is a 0, sine 270, which is minus 1, sine 360, which is a plus 1. Not a plus 1, but a 0 there. Okay, so make sure that you use your calculator properly. So then, and also that your calculator is in degrees. Here we are in degrees, guys, so make sure that your calculator is in degrees. Once you can do that, then actually you can be able to now draw. So I'm having this here, a presentation, just a smaller presentation, guys, like your x and y, like that. So you just need to mark your points, 0 versus 0 there, which is at this point here. Then we've got 90 degrees versus 1, so it's 90 degrees versus 1, which is at this point. Then 180 degrees versus 0 there, 180 versus 0, which is here, then 270 and minus 1, so this is 270 and minus 1, 360 and 0, like that. So that's what you just need, guys. You mark these points, then you join those points properly. So as we can see, that's how it is going to look like. So these are the intercepts with the axis, and these are your turning points. This one is a turning point, and also this one is your turning point. Okay, so actually this is the graph of y is equal to sine x from 0 to 360. So just use 90 90 90 like that, so you can actually draw a better one in this way, and it can seem to be much easier also that way. And that's how it is actually. Then on question number 8, which is actually the last part that we had of the paper, where we are given Sami is building a 1500 piece puzzle. He has already completed 5 out of 12 of the puzzle. How many pieces does he still need to build? So take note, guys, he completed 5 out of 12 from this total of 1500. So which means how much has he completed? If he has completed 5 out of 12, so you simply multiply by 1500 to know the ones that are completed. So this is going to give you 625. So actually, out of 1500, 625 are the ones which are completed. So which ones now are not completed? So it's 1500 minus 625. You subtract to obtain a difference of 625, which is the one that is still need to build. Okay, or you can play around with the fraction. You can actually play around with the fraction, because 5 out of 12 is the one that is completed, which means the remaining out of 12, 12 out of 12 minus 5 out of 12, that is the remaining, which is going to give us 7 out of 12. So this is our remaining, or the one that is left to be built. So we are just going to use that as a fraction. 7 over 12 times how many bricks, how many puzzle pieces are there? 1500. So these are the puzzle pieces. So definitely you can obtain the same thing, which is 875, just like the other one. All right, then a landscaping company needs your help in planning the layout of a garden. The 3D image below shows a right cone inside a rectangle. Okay, so this is like a rectangle, like a 3D view that we are given, and this is a cone here. As you can see, guys, we are given a cone there. The rectangle represents the lawn and whatever that we are given, floors and plant along a perimeter of a rectangle grass plot. Okay, then on 8.1, calculate the perimeter of the rectangle grass plot. Okay, so this is the rectangle, guys, and we know that perimeter is actually the distance right around the shape that you are given. Or you can maybe just try and cross check on your formula sheets and so forth. Perimeter of a rectangle, you're given here 2 into L plus B. You are given the perimeter of a rectangle, guys. So if you have forgotten this, then you can just use your formula sheet, which is 8.21, which is perimeter is 2 into length plus breadth, which is 2 into length plus breadth. Our length, longer side, is 12, and here it's 8. So it's 12 plus 8, just like that, guys. And 12 plus 8, which is 20, and which is going to give us 40 meters. So perimeter, no square units. There's no square unit there. Okay, then now calculate the volume of the right cone structure with a height of 4 meters and a radius of 2 meters. This is a cone structure, and we need the volume. So from your formula sheet, also the formula, this is 8.22. The formula for the volume of a cone is given, but this is actually a third pi r squared h. All right, this is a third pi r squared h. If you are not quite sure about that, then you can cross-check this one. Pi r squared h over 3. This is just like a third pi r squared. It's one and the same thing. Okay, so that's what you're given there. So which is going to be a third times pi times r there, which is the radius. So as you can see, the radius of the cone is 2 meters. That is the radius of the cone throughout there. So we've got 2 meters. So it's 2 squared times the height of the cone. So this is actually the height of the cone, which is 4 meters. All right. So if you use your calculator properly, this is going to give you 16 over 3 pi, which is in cubic meters. So that's the volume. Or you can write it maybe as a decimal, which is 16,755 cubic meters. Write it as a decimal. That was the idea there, just like that. Then calculate the area where the grass must be planted. Keep in mind that the base of the cone structure in the area does not need to be fitted with grass. Okay, which means, guys, we need the area that is going to be actually surrounded with grass, which means we're talking about this region here, guys. Okay, so I don't know, guys, if this is going to work, but we are referring to all this region that you're going to have here, but this part is going to be excluded, is going to be removed, this one. And what we have here, we have got a circle here from this base of a cone. On the base of a cone, there is a circle. So we are going to take the area of a rectangle, this one, minus the area of a circle, which is on the base here. We are going to remove this circle because there's nothing that is going to be planted there. All right, so our area to be planted is going to be area of a rectangle, which is length times breadth, minus the area of a circle, which is to be removed. So this one is to be removed. So you're going to remove a circle, which is pi r squared. So this is the area which is going to be having the grass. Area of a rectangle minus the area of a circle. So the total area is going to be area of a rectangle, which is length times breadth, and the length is 12 and the breadth is 8. So it's 12 by 8. So we are going to have 12 by 8 here minus pi times r squared, which is the radius. Remember, this has got a radius of 2 meters. So it's going to be 2 squared. All right. So that's going to be 96 here minus 4 pi, but we can't leave our answer like this, guys. Okay, we have to simplify further, which is going to give us 83.434 in square meters. So take note, this is area, and area is measured in square meters. Okay, so actually, guys, that's what we had, and this marks 4 marks to make a total of 11, and to make a total of everything from the question paper, which was making a total of 100 from this question paper from our June-July 2022 exam. So that's what we had, guys, for mathematics N1 final exam. So if there is anything, guys, any errors, any mistake that you've seen or that you think they are there, let me know on the comment section so that actually we can work on it together and see which part actually, or which part exactly, and what is supposed to be done. So that's it, guys, from us on African Motives, working on N1 mathematics, in fact working on engineering related studies. Till we meet again.